Hello and welcome to Forrester High School Maths Department's National 5 Math Support Materials. My name is Mr. McDonald and I'll be talking you through your topic today. Today's learning intentions are to be able to find lengths of right-angled triangles using Pythagoras Theorem. This is something you should have seen before in National 4, but we're going to make sure that that foundation is nice and strong before we take on any National 5 Pythagoras Theorem work. So let's recap on what you should know already. Pythagoras' theorem states that c squared, the longest side of a right-angled triangle squared, is equal to a squared plus b squared, which is the other two sides of the right-angled triangle squared and added together. Okay, so if you're using the top equation, c squared equals a squared plus b squared, you already know these two yellow sides on that top triangle. And what you're looking for is you're looking for the longest side, which is called your hypotenuse. That's c squared. You know which one your longest side is because it is always opposite the right angle in the right angled triangle. Okay, so it doesn't matter how your triangle is rotated, it's always the one that is opposite the right angle is the longest side. And if you're trying to find it, you use c squared equals a squared plus b squared. On the other hand, if you're missing one of the shorter sides, I'm going to say that we know the two sides in yellow, but we're looking for one of those shorter sides, then you use a squared equals c squared minus b squared. And that pink side that you're missing, the shorter side, is going to stand for your a, and the one that you know is going to stand for your b. It doesn't matter which side that is smaller that you know and which side you don't. You can always just label the side that you don't a and the side that you do b. That might be a little bit confusing, but let's just have a look at these two triangles here. Okay, which one of these are we going to use c squared equals a squared plus b squared for, and which one are we going to use a squared equals c squared minus b squared for? Pause the video here, see if you can figure out which one's which. Hopefully you said that the triangle on the left hand side needs to be using c squared equals a squared plus b squared. The reason for that is because the side that is opposite the right angle, that one there, is missing. That's our hypotenuse, the longest side. So we are using c squared at the start of our formula, which is the longest side of the triangle. That's the subject of this equation. For the second one, hopefully you said that it's a squared equals c squared minus b squared that works there because we're looking for a smaller side. A squared is the subject of the formula, and indeed we have one of the smaller sides that are next to the right angle rather than opposite it. It could have been this side that was missing, and we'd also have to use a squared equals c squared minus b squared for that too. Okay, so here's a quick example. On this triangle, which of my sides is missing? Is it the hypotenuse or is it one of the two smaller sides? Well, in this case, it's not opposite the right angle, it's right next to the right angle. It is a smaller side. So I'm going to write down my smaller side formula. A squared equals c squared minus b squared. My second step is I'm going to substitute in the numbers that I know about. So a squared is going to become x squared because that is the side that I'm trying to find. C squared is the longest side, so that's going to become 70 squared. And b squared is the other side that is smaller, that's 58 squared. Putting those numbers into a calculator, you get that x squared is 4,900. Take away 3,364. A little bit of mental maths involved here. If we do 4,900 take away 3,364, we are left with 4,536. Now the last step here I need to figure out how to get from x squared, which is my side length squared, back to just x. And the way we do that is undo the square on both sides by square rooting. So the final step is you get x is equal to 67.35. Remember, because we're looking for a side length, we should have units on the end. So referring back to your diagram, everything's measured in centimeters, so is that final answer there. Here we have a second example. What we've got is we've got our missing side this time opposite the right angle. So that means that we're going to use our hypotenuse version of Pythagoras theorem. We're going to use c squared equals a squared plus b squared. Putting in the numbers that we know from our diagram, c squared we don't know the value for, so we just have to use the letter that is holding its place so far. So p squared is equal to 19 squared plus on 36 squared. Putting those values into a calculator, you'll get that p squared is equal to 361 plus on 1296. Add those things up, and you're going to get that p squared is equal to 1657. And to find p when we have p squared's value, remember we have to undo that squared by square rooting on both sides of the formula. Your final answer for this is p is equal to 40.71. And again, referring back to the question, centimeters for that length. Could be millimeters, could be meters, could be kilometers. There's lots of different applications for Pythagoras theorem, but for now, let's just focus on working with triangles and not having a context as part of this. Well done, Nat 5s, on completing this video. Remember, if you have any questions, you can ask me those questions through our virtual live chat, on Show My Homework, or through email. You can do it. Make sure that if you have any problems, you ask me about them. If you have any requests for support, then let me know. And remember, once you've got your final solutions, upload those to Teams. Well done, Nat 5s, and thank you very much for listening.